what is our next question? So fourth A question is find the current Ix using superposition theorem. Now if you see here, we have two voltage sources. One is for 36 volts, another is for 12 volts, and we have a current source of 6 amperes. Now Ix is the current which is flowing through 5 ohm resistor, correct? Now in superposition theorem, what we do is we consider one voltage source or one current source. In short, I can say that here we consider only one source at a time. We calculate the corresponding current, and after that we add these individual currents, but we have to consider the direction also. Fine. So we add all currents and we'll be getting the final current. Okay. So the very first thing is we will consider one source at a time. So first part, let us consider 36 voltage source alone. Fine. So now let us draw that circuit diagram. Now another voltage source, here we have a voltage source, isn't it? So this is a voltage source, so it has to be replaced by a short circuit. Okay. And then we have a 5 ohm resistor and current source will be open circuited. So we do not have anything here. So this is 5 ohm, 10 ohm. And again this is 5 ohm resistor. Here we have 36 volts. Now current Ix is this. So let me represent this current as Ix1. Now we can understand that actually this Ix1 is nothing but the total current due to 36 volts, right? So first let us understand what is the total resistance. Okay. So what is the total resistance? Now if you see this 10 ohm and 5 ohm combination, it means that 10 and 5 are in parallel. And this combination is in series with 5 ohm resistor, right? So what is the combination of 10 and 5 parallel? It is 10 into 5 upon 10 plus 5. Now this is 5. So it is 50 upon 15, which comes out to be 3.33 ohms. Okay. So the parallel combination of 10 ohms and 5 ohm make it to be 3.33 ohm. And this 5 ohm is in series. So what is the total resistance in this case? 8.33 ohms. Correct. So we have calculated the total resistance. Now how will we calculate this current? Simple Ohm's law. That is the total voltage upon the total resistance. Now the voltage is 36 and the resistance is 8.33 ohms. So the first current, which is Ix1, comes out to be 4.32 amperes. Now this is positive, so we are not mentioning positive explicitly, right? So this is our first part. Now let us erase it, and now we will be starting with the second part. So second part will be, let us consider 12 volt source now. Now here 36 volt source will be replaced by a short circuit. Now we have a 12 volt source. Again current source will be open circuited. So here we have 5, 10 and 5. This is here now 12 volts. Now again if you see, this combination is a parallel combination, then it will be in series with 5. So what is the total resistance in this case? It is 10 in parallel with 5 and it is in series with 5. So we know that already we have calculated the parallel combination of 10 ohms and 5 ohms comes out to be 3.33 ohms, which is further added with 5 ohms. So my total resistance in this case also becomes 8.33 ohms, right? So now the total current, this current is due to 12 volt source. Now please understand here. Now here this is 12 volts, right? So this current is the total current here. Now Ix is the current which is flowing through this, right? But here the total current meets, see at this node it gets divided into two parts, right? Some current flows through 10 ohm resistor and some current flows through 5 ohm resistor. Now let this current be Ix2. Fine. So here we will be calculating the total current. Total current will be 12 upon 8.33. So that current comes out to be 1.44 ampere. Now this is not IX2. Okay. Now in order to find IX2, we have to consider, now I have not specified the direction, I'll tell you why. Now what is going to be the current which flows through 5 ohm resistor? We can find this current by using current division rule, right? So it is the total current multiplied by the opposite branch upon the total branch. So what is the total current? 1.44 multiplied by 10 divided by 15. Now IX2 will be 0.96, yes, amperes. Now why I did not specify the direction yet? Because here the total current is flowing from right to left, and hence the current which flows through 5 ohm resistor also flows from right to left, whereas my IX2 will be in the opposite direction, right? Okay, so actually this current will be minus. So that is why I did not specify in the beginning, because I wanted to explain it to you. Fine. So my IX2 is minus 0.96 amperes. I hope this is clear to you. Yes. So again let us erase it, and finally we come to 6 amperes current source. Yes. So here we have 5, 10, further we have 5, and then we have a 6 amperes current source. So this is 6, 5, 10, 5. So what we will be doing is, if you consider this combination, again 10 and 5 are parallel. So we know that this combination is 3.33 ohms. So further I will reduce this. So this becomes my reduced circuit, right? So this is 6, 3.33, and now this is 5. Now again pay attention that this current is flowing in this direction, so this gets divided into two parts. Now this will be IX3, correct? But please pay attention that IX is in this direction, right? So now this current of 6 amperes is getting divided into two parts. So again we'll be making use of current division rule. So that is going to be the total current multiplied by the opposite branch divided by the total resistance. The total resistance is 8.33. I'll just calculate this and then I will write the value. Okay. So it is 6 multiplied by 3.33 divided by 8.33. Yes. So it comes out to be 2.4 amperes. Now again see, the current is actually minus. Okay. Fine. So one current is positive, another two currents are negative, right? So let us go to the next slide. Now what is going to be the total current? It will be the sum of all the currents. So it is IX1 minus IX2 minus IX3. Now see, I will not put minus for the current again because I have already considered their magnitude. So what was IX1? It was 4.32. IX2 was 0.96 and IX3 was 2.4. So it is 4.96 minus 0.96, sorry, 4.32, yes, minus 0.96 minus 2.4. So the answer comes out to be 0.96 amperes. Okay, so this is the answer. Fine. So let us go to the next question now. Now it says that a resistance and a capacitance connected in series across a 250 volt supply, draws 5 amperes at 50 hertz. Okay. So first we have a resistor and a capacitor. It has been connected across a supply. Supply is 250 volts, 50 hertz. In that case, the current is given as 5 amperes. So this is R and this is C. Okay, fine. Next part says when the frequency is increased to 60, it draws 5.8 amperes. Okay, it means the circuit elements are same. Everything is same actually, but the frequency is changed. Now it is 60 hertz. So the current becomes 5.8 amperes now. Otherwise, the value of R and C remain the same. So we have to find the value of R and C and active power factor. Okay. Yes. So it is actually, I think there is a mistake. It is not power factor, it is power in both the cases. Fine. So it is actually power in both the cases, right? Fine. So what we will be doing is, first let us consider 250 volts, 50 hertz. Okay. So now we have current and voltages, right? So V is 250 volts and current is 5 amperes. So what can we do? We'll be getting the value of Z here, that is V upon I. So it is 250 upon 5. So that makes it 50 ohms. So we got the value of Z. Now if you have a series combination of R and C, then how are we going to calculate Z? It will be, I'm talking about the magnitude, right? So it will be R plus XC square, right? So I will further solve it because I know that XC is equal to 1 upon omega C. So I will place this value. It becomes R square plus, what is omega? 2 pi F. So I will write the value. Correct? Z came out to be 50. R square plus 1 upon 2 pi into 50 into C, this whole square. Correct? So my equation comes out to be 2500 is equal to, wait, I forgot to remove this sign. Yes, because I have squared it, right? Yes. So it becomes 2500 equal to R square plus 1 upon, I did the calculation and I got the answer to be 98,596 C square. So this is equation number 1. Now let us talk about case 2. Case 2 is frequency changes to 60 Hertz and current changes to 5.8 amperes, whereas V remains constant at 250 volts. So again we will be going through the same procedure. First we will calculate Z, so which comes out to be 250 upon 5.8. So Z comes out to be 43.1 ohms. So again we'll be using the same equation. So I'll be squaring it on the both the sides. So it becomes Z square is equal to 1 upon Z square is equal to R square plus 1 upon 2 pi FC square. So I'll be placing the value. So it becomes 43.1 square is equal to R square plus 1 upon 2 into 3.14 into 60 into C whole square. Correct? So after solving this, we get 1857.61 equal to R square plus 1,41,000 978.24. Such a big number, isn't it? C square. So this becomes equation number 2. So now we got equation 1 and equation 2. When you subtract equation 1 from equation number 2, r square will get cancelled, and then we will be getting the value of C here. So after solving this, the value of C comes out to be 69.42 into 10 raised to power minus 6 farads, or that can be written as 69.42. 10 raised to power minus 6 means microfarad. So we got this answer now. So when we put the value in any one of the equation, we get R to be 19.94 ohms. So we get this answer also. Okay. Now let us calculate the power. What is going to be the power? It is I square R. So 5.8 square multiplied by 19.94. So that comes out to be, the power comes out to be 670.78 watt. This is when the current is 5.8 amperes. That is case number 2. If we wish to calculate the power for case number 1, so it will be 5 square into 19.94. Okay. So it is 25 into 19.94. So the power comes out to be 498.5 watt. Okay. So let us go to the next question. Now suppose, see, I said we had to calculate the power, right? Not power factor. But had it been power factor, then how we would have done that? Can you tell me that? Now, if you want the power factor, first let me erase this. It just came through, my mind that, okay, if that happens, what we would have done. So before going to next question, let us just discuss that. So here we have two powers, isn't it? P1 and P2, and we have calculated those powers, right? So if you talk about power factor, it will be VI cos phi. But instead of, see, I will not write V1 because V is constant, but I can write I1 and cos phi 1. Similarly, here V is same, so I will write V, but I is different, so I will write I2 cos phi 2. Correct? So I have calculated P1 and P2. Correct. So what I will do? I will do cos phi 1 is equal to P1 upon VI1. Similarly, here cos phi 2 will be P upon VI2. So the point here I wish to convey is that we can do that. I mean, even if it had been power factor, we could have calculated because we have all the values, right? Yes. So now let us go ahead. Now here they said find the node voltages V1, V2 and V3 and the current through 0.5 ohm resistor. Okay. So what we have to do is, they have already given V1, V2 and V3. So first we will proceed with node 1. So apply KCL at node 1. Nodal analysis is KCL, isn't it? So here we have 4 ampere current source. So it will be V is equal to. Now we will first go in this direction. So it is V1 minus V2 upon 0.33. Next in this direction. So it will be V1 minus V3 upon 0.5. Okay. Further, we will solve this as V1 upon 0.33 minus V2 upon 0.33 plus V1 upon 0.5 minus V3 upon 0.5. Okay. So when we solve this equation, we get 5.03 V1 minus 3.03 V2 minus 2 V3 is equal to 4. So this is the first equation for node 1. Okay. Now, if you consider node 2 and node 3, they are called super nodes. What is the meaning of super node? Now, what was super mesh? When you have a current source in between two meshes. Similarly, when you have voltage source between two nodes, it is called a super node. So first we will write this equation. Now see, where is my positive terminal connected? Now this is positive terminal is connected to V3, and hence V3 will be positive and V2 will be negative. So what is the equation for super node? It is V3 minus V2 is equal to 5, and it is not V2 minus V3 because V2 is negative and V3 is positive. So now this is equation number 2. Okay. So what we will be doing is, now we will be applying again. Let us consider node 2. Fine. Yes. So what will be the equation? Now here it will be V2 minus V1 upon 0.33 plus this, it is V2 upon 0.2, correct? Plus, now here we need not do anything directly, we can write this because actually it is 2 and 3. So I should write 2 and 3, yes. So now it is V3 upon 1 plus this also, correct? So it is plus V3 minus V1 upon 0.5. This is equal to 0. So when we solve this, we will be getting minus 5.03 V1 plus 8.03 V2 plus 3 V3 equal to 0. This is equation number 3. Okay. So we got these equations. So after solving these equations, we will be getting the value of V1 and V2. So V1 comes out to be 2.62 volts. V2 comes out to be minus 0.17 volts. Now please pay attention that here V2 is minus. So I already told you that V2 is going to be minus, right? And finally V3 comes out to be 4.83 volts. Fine. Okay. Yes. Now if you go back to the circuit diagram, let us quickly go to the circuit diagram. What is the current through 0.5 ohms? How will you calculate the current through 0.5 ohms? Come on. So let me represent it by 0.5. Okay. So it will be V1 minus V3 upon 0.5. Okay. So it will be 2.62 minus 4.83 upon 0.5. So it is 2.62 minus 4.83 divided by 0.5. So it comes out to be minus 4.42 amperes. Now see, if I have considered, now this is 0.5 ohms, okay? This was V1, this is V3. Now I considered the current to be V1 minus V3. It means that I considered this to be positive and this is negative. But since the current has come negative, it means actually it is flowing in this direction. So what I'll write is, suppose this is 0.5, then I will write this is the current direction. Okay, and this is 4.42 amperes. Done? Okay. Next, Describe the basic principle of operation of single phase transformer and derive the EMF equation. Now, as I've already told you that we have discussed the principle of operation of single phase transformer in the 4th chapter. So you can refer to that lecture, and today's lecture we shall be meeting in the concluding part of this question paper in the next part. Thank you.